Really, the amazing thing about modern speaker building as opposed to the way it used to be done was it was much more trial and error, but now we can simulate the system. And when we build the speaker, it is very, very close to the simulation because of the tools that we have.
Welcome to SCL Podcast, filmed in the MD Acoustics Anechoic Chamber in beautiful Gilbert, Arizona. Today we are joined by Colby Buddelmeyer, a multidisciplinary engineer whose talents have been employed by the likes of Samsung, Apogee, Boeing, and Harman Luxury Audio. Each episode we bring you compelling conversations, practical advice, and illuminating stories from the minds of industry leaders, educators, innovators, and visionaries who are shaping the world one idea at a time.
I'm great. Thank you guys so much for inviting me. It's really an honor and a pleasure to be here to join you on the SoundCave Lab.
We're really glad you're here, and we really appreciate you coming on. It looks like you've done a lot of stuff in the audio engineering world, and we'd love to know more about that.
Well, my audio career started in 2004 when I joined Rebel Speakers, which is a luxury brand within Harman International. I had the fortune of having someone recognize that while I didn't have the pedigree in audio, I had the passion. And they gave me a chance, and I've always been grateful for that opportunity and tried to pass that opportunity back on. So I started actually working on their low price line called the Concerta speaker range, and developed that series of speakers, and then transitioned on into the Ultima 2 series, which is the luxury, high-end luxury version of their product, of which I eventually did the mechanical and industrial design, co-industrial design with another talented engineer named Mark Ellis. Taught me a lot about doing surfacing, using Pro Engineer, which was extremely challenging. So I did that, and was fortunate enough to deliver a speaker, the Salon 2 of which was designated the Absolute Sound Cost No Object Speaker of 2007. It was actually on the cover of one of the issues. And I'm really proud of that work. It's not very often that you get to have that kind of accolade for something that you make. I mean, I make things really for myself and for other people, and to make something that wows and impresses the consumer, but you don't always get rewarded for it. And that was really something special.
I have a follow-up question about your experience there designing a new line of speakers for Harman. In university school engineering, when we learn about loudspeaker design, we learn about lumped element analysis and kind of do all of these circuit design parameters. But what are some of where do the design constraints that you optimize for come from?
Well, I mean, it's kind of funny to ask, and I get asked oftentimes where a speaker or a product comes from. It really depends oftentimes on what place you work at. Some places the designs flow more from discussions within the executives. Some places it comes more from industrial design. At Harman, I think it really comes from understanding the customer and the marketing. And so the marketing team is very strong there, and they understand the customer, and they will create a product requirements document. That PRD will flow down to the engineers, who then will create some engineering requirements documents, and then an industrial design will be made, which results in a color material finish CMF document. That's the ID telling us exactly what it should be, how it should look. Mechanical engineering starts in earnest then, and we work together with the transducer engineers to make sure that we're designing the system to fit all of the acoustic requirements for the transducers, and with the systems engineers so that we understand will the system work for the tuning that's required. And they're really doing the analysis, basically the system synthesis, as we would call, and looking at the system through a series, as you said, of lumped parameter analyses. We will take measurements of the transducers, and typically the system analysis will result in a series of teal small parameters that do give us a roll-off, a low-frequency roll-off that helps us to understand how to design the system. And so really the amazing thing about modern speaker building as opposed to the way it used to be done was it was much more trial and error, but now we can simulate the system. And when we build the speaker, it is very, very close to the simulation because of the tools that we have, both the clippable tool for analyzing the speakers and the proprietary tools that we have for actually doing the lump parameter analyses. And now we're getting to the point where even doing, the old systems like LEAP or whatnot, they were pretty much linear, but now we're getting to the point where we're taking the nonlinear parts of the equations into account so that we're really dialing in on the system synthesis.
You mentioned something real quick, and I have to ask. You mentioned lump. All I know is when I hit my head, I get lumps. What is that? How does it pertain?
Before there was computers to do all this analysis, so you could do finite element analysis, boundary element analysis, people need to do all this stuff by hand. And so they're still doing that. And if you've ever used LT Spice or something like that, where you're analyzing an electronic circuit, that's really what it's doing. This is just an acoustic analogy for something like that, where we're taking the acoustic, we're doing dynamical analogies where we're comparing the acoustic and mechanoacoustic, electroacoustic parameters to circuit elements, and then using those circuit elements to simulate the way that the system functions.
This is going over Robert's head, I can see, because here's the thing, right? I just want to say, so just to our listeners, by the way, our podcast, we want to hit kind of everywhere in the engineering space. Primarily, though, we're looking for the younger, up-and-coming generation, folks that are entrepreneurial-driven, engineering-driven, on all that stuff. But when you talk about electrical, right, you're talking electrical signal, equivalent circuits, right? You're talking about all these things.
Basically.
When you get into college, this is not high school level stuff. You start learning, right, Samuel, in the programs, you're learning about taking from what they say one domain, the mechanical domain or the electrical domain, and you're converting that into the audio domain or the acoustical domain. And so you're talking and you're using these big terms, which somebody listens to and they're like, okay, but they're not going to understand that. And then the scientist or the engineer would go, oh, okay, I understand that. Yeah. And it was like the first, year or two in college that I was like, it was just like, you're drinking water from a faucet. It's just a lot coming at you. So it's good stuff in terms of understanding that for the listener, but also I would sit there and say, do you have younger folks or generations that come to you and do they understand that? Or is this something that people let's say you have younger staff or junior level staff, are you, pointing them into your direction and say, hey, no, you need to go read this tutorial, or, what kind of training is there? Or how does somebody that's interested in loudspeakers, how do they learn about that?
When I have had new employees, especially PhD level, who come in and are interested, and masters as well, in acoustics, I tell them to read Beranek.
Okay.
That is the old school. It's I guess the first edition is probably from late 40s, 48 or something like that. And there's been newer treatments of his work, but he's probably one of the most famous of all acoustic engineers, Leo Beranek. And his groundbreaking work that is based on some of the work also done by Harry Olson, it really does give you the treatment and the background to understand all different aspects of acoustics and design of acoustic devices. And when you start getting into lump parameter analysis, there's Olson has a book that's basically just on that. And again, nowadays you probably really don't need to know that stuff because you just have the tools and you can just use the tools. But it's like if you wanted to be and go and make networks passively by hand and do the calculations, you can go find the books and they'll teach you how to do it. Do you need to do that nowadays? No. You're going to do it in MATLAB. You're going to do it in some other tool to do it.
Outside of books, what would you do beyond that? Is there other tools, like you're saying in MATLAB, you're saying these things, but is there other YouTube tutorials? Think about this. Think about who are we trying to teach here? If you've got a 14-year-old prodigy, where are they learning this? Are they literally cracking open the 1948 book from Leo Beranek, which is, honestly, that's old school.
That's true.
Right? But is there tutorials, or are companies keeping this stuff close to the chest, right? And saying, no, we're not really. Because I remember as a kid cracking open the radios, all the loudspeakers, right? Pulling everything apart and learning that way.
I think that's true. Certainly there's tons of online resources. I actually find myself using Wikipedia to look up things that I'm interested in. And that's a gateway to me to learn all kinds of things. You can take that and jump down the rabbit hole and take it as technical as you want to get. And certainly I find lots of interesting information online related to speaker building that's not at the extreme technical level. And then there's also sources like the Audio Engineering Society. I think they've somewhat opened up their library so that you can peruse their library. And of course, many of the most famous papers ever written on acoustics are available there. Again, those do require you in many cases to have almost an electrical engineering degree to understand them, because acoustics, especially acoustics for loudspeakers, is all based on signal filtering theory. And so that's all stuff from radio and, stuff that you don't really learn in normal school. So I think that might be one reason why electrical engineers have always been interested in it, is because one, it's something that we can bring home with us, and it's something that we can enjoy on our own, and it's challenging.
You bring up a good point, because you said audio engineer as opposed to an acoustical engineer. Here we are sitting in an anechoic chamber. You use anechoic chambers, hemi-anechoic chambers. Why the term audio as opposed to acoustical?
I wouldn't say that they're not interchangeable, but I think audio is more general, where you're probably working on all kinds of aspects of audio, whereas acoustic really is how does sound work in a room. It's more physics based, I think, as opposed to audio. Myself right now, I'm currently managing people, so I'm not doing day-to-day acoustics, but I am making and doing audio product development.
Gotcha. Okay.
Yeah, Mike was completely right when you were talking about certain things, and he's like, it's just going right over Robert's head. It really is. However, what I was impressed with is, from like a business standpoint, how much goes into looking at these speakers. You're working for luxury speakers. People want a luxury product. Here we work with a lot of things that are luxury in sense, and people expect them to perform like a luxury apartment or something of that nature. And when it doesn't, they're not very happy, right?
Yeah.
Now you worked in a luxury brand for quite a while, and then you made the jump over at some point to Beats by Dre. But you worked on some pretty good things, really good products I've used in my life, like the pill. The pill was everywhere when that thing came out, right?
Yes.
But tell me kind of what's the difference between something like a Beats by Dre and, Harman luxury?
Well, I think, when you talk about the type of Beats product, it's something that's more on the go, whereas the luxury products are typically more static.
Okay.
They're not really going to be taken around with you usually. That's not to say not always. You could have some high-end speakers that maybe come with you, but these speakers are meant to be portable. I honestly will say, not that I am denigrating or trying to reduce the level of effort that's required to make a luxury product, but making the Beats headphones and making wearables is probably the most challenging mechano-acoustic product that I've ever worked on, because the requirements compete against themselves. So you need to have something that's robust enough that you can drop it onto a steel plate from 6 feet, but it has to be light enough that you want to wear it on a plane for 18 hours or whatnot. And then it also has the electrical and the battery requirements, and it has to sound good, and it has to look beautiful. On the Salon, the Studio 2 headphone, which I was the lead engineer on from the standpoint of delivery, and worked with amazing outside contracting firm for the design portion of it. It had about 150 components in it. You wouldn't think that. And it has every kind of material you could imagine other than wood in it. So it was extremely challenging. It's also, luxury definitely operates on a very tight timeline, but the Beats products, I think, were even tighter in that we had to get shelf space at a particular time at the different customers. And if we didn't do that, we were going to lose our Christmas. Really the luxury product that I've worked on, the Rebel stuff, is most of the time is not super heavily dependent on Christmas sales. Mark Levinson, I think, is also kind of like that. Not that we don't want to meet Christmas, we do, but Beats was living and dying on getting that shelf space. Yeah. So, and the ramp up, the grassroots ramp up had to start very, very early. So When I did the Beats pill, that was told to me that like it was a must. It had to be on the shelf and be ready to ship by mid-September. And we didn't start until, I want to say April probably, or end of March. So it was a very tight timeline to make that product basically soup to nuts. There was a very tight delivery schedule to make the product.
That leads to one of my questions. When it comes to product development, a lot of times the specifications or the technical requirements are decided at the beginning of the project, and then there's got to be somewhere between that, yeah, we can totally do this, and getting it on the shelf, there's got to be that, oh crap moment, this isn't working. Can you tell us about one of those that you had?
I always want to be pretty general, because when you have that, you're having essentially a failure of either management or some part of the compliance process or something with the product. I have had that happen. I won't specifically say who it was with. It resulted in a product actually having an explosion in one of the test chambers.
No.
Essentially delayed the product. And, we had to really make some very, very tough decisions about was the product going to move forward? When would the product be for sale? And what was the cause of that failure? So it was something that really, it was a very, very, very demanding and very tough period of time for me, where we were actually realizing that it seemed like for the best thing of everyone that this product needed to be put on hold, but for the best business case of the business, it needed to be launched. So that's a very challenging position to be placed into.
So you're telling me that exploding products going out is not a good thing?
It's not a good thing, and that's why we do what we call HALT, highly accelerated life testing, and make sure that the products are safe. And all the products that I've ever worked on for release are always tested that way and are ensured to be safe. This product was no different than that. The testing continued, and the product was deemed to be safe and was put for sale.
Let's talk about testing real quick, because this is good. I was going to say, because we test a lot of product here, right? We actually help design and develop product.
Nothing's blown up.
Nothing's blown up, thank goodness. We make explosions here and there. But I would say this, I personally have walked a lot of production lines, prototypes, this and that, right? So really quickly, in the facilities or wherever you're working, by the way, we haven't even mentioned, you worked at Samsung, shout out to them, shout out to, I would say, Matt McDuffie, who we have mutual friends, right? And Matt was a former employee of MD Acoustics. So I would just shout out to Matt. We give you a lot of love if you ever hear this. I was just like, man, some engineer someplace tested this out. It was amazing. And I got to imagine, because you're sitting there talking about the pill, you're doing stuff like this. Obviously acoustics is one component of this. What other things are you testing? You said like drop it from 6 feet to steel plate. Do you guys have any cool things that you do to test these kinds of things like reliability?
Yeah, every product. And I learned all that stuff from Harman.
Okay.
We would do all kinds of crazy testing there. It would have a couple different types of vibration. We would have vehicle vibe, which is more of a high frequency vibration, where it's put on a shaker table and slip axis and vertical, and it's shaken in a few different directions to a particular G profile. And then we would also do loose load, where it's in all these cases it's being done in the shipping packaging. And the loose load is pretty crazy, because it's basically like assuming the last so many miles where it's on a truck, and maybe that truck is getting jostled around. And part of the requirement of the test is that you be able to take a stick and run the stick under the thing while it's being shaken, meaning it's being lifted off the table enough that you can run a stick under it. So we would do that. We would do all kinds of thermal testing. And I've never had another product that blew up in a chamber. That was a very, very strange.
That's like a one-off.
Yeah, it doesn't happen often.
Batteries in it. And the vendor said the supplier said that they felt like that the thermal chamber went into runaway. So it's very possible that that's what happened.
Do these follow like
so-
ASTM guidelines and the testing, or IEEE, or what kind of for that testing? I'm just curious, just to put out for standards.
Usually I think the testing is informed by these different bodies.
Okay.
And then it depends on what the supplier, actually the customer wants. So whoever I was working with, and one of the things that I did when I was at Beats, because I didn't really have any experience building headphones at that moment, and also because the end between Monster Cable and Beats basically resulted in there not being a lot of engineering documentation, because Monster Cable had been doing the primary, and everybody knows the primary engineering. They were working to deliver the product. So we really didn't know a lot about the product. And so I pretty much just would go in and say, well, I don't really know that much about the product. So we're going to make I was put in there in order to make sure that the quality of the product, the robustness of the product went up dramatically. And so I would just make the test spec. I would look and find what other people were testing to, and I would make it tougher than that.
That's
I
cool.
would try to make it as tough
nice.
as I could make it. They'd come to me and be like, there's no way we can pass this. I'm like, all right, well, show me you can't.
That's really
And
cool.
the suppliers did not like that.
No, that's really cool, because I think I was talking to Samuel right before we did this, and he mentioned how in engineering school, like a lot of people say, something like a Bose was designed on engineering and Beats is designed on marketing. And you just basically put an end to that discussion by saying, I took a lot of the things I learned from Harman and then founded the Beats mechanical engineering department or team, and used a lot of that same stuff to up the quality, to up all these things. And that should make people think a little bit differently on some of the product that's out there.
Beats is a very marketing driven company, 100%. And that
Absolutely.
was part of the DNA of what Beats wanted to be. But the product, and not just because I worked on it, it is very well engineered. It is a very well designed product. The suppliers we worked with were world-class suppliers. The team of engineers that I had the fortune to work with were world-class engineers. And in the end result, I can't say what it's like now that I left the company actually before Apple took over, but
Okay.
you better believe that anything that Beats was lacking before, Apple made up the difference.
I'm sure.
So
Think so.
I do believe that their products, you can question whether you like the products, whether you like the industrial design, whether you like the sound, but the quality of those products is absolutely stellar. And really what you're getting, what you're paying for is actually a very well engineered product for what you're paying for. There were a lot of videos of people who had actually had taken the product and broken it on camera. And I was instructed that could not happen anymore. And so when we redesigned the headband, we actually did make a test fixture at the supplier where the headband was stretched pretty much flat, and we just let it go, and it went for 20,000 cycles, and then we're like, let's just turn it off. None of them failed.
That's awesome.
And we actually had a guy that played for at USC. He wasn't a primary player, but he played and sparred with the team. And this guy was a big guy. And I gave him the headphones that said, break a pair of them. And he couldn't break them. So
Awesome.
they're tough. They're really, really tough. They're made out of an extremely tough type of nylon, the headband. So it won't crack now. The original ones were made out of polycarbonate. And, polycarbonate, it's beautiful and you can finish it very nicely, but it's not good for crack propagation. When it starts to crack, it just shatters. So that was something that I was brought there to solve as well. That was a specific problem that I was brought in to fix. And I definitely did not fix that on my own. I just led the team and we did it.
Nice.
To throw you a curveball here, so when we talk about loudspeakers or like headsets or anything like that, I grew up in Southern California, so I was born and raised in Simi Valley, California, and you are living in Southern California, correct?
Yes, that's correct.
And I think of growing up and being in the vicinity, there was so many loudspeaker companies in the vicinity that have since they've all they've gone belly up or they've been acquired or whatever it was. And then I didn't realize that, Harman they have their facility there, the JBL facility right there in Northridge. Is that where you're at currently then, or where are you at?
I'm at on 8500 Balboa, where I used to work in 2004. So it's really like a homecoming for me. I've come full circle.
Full circle. So now you're there, and by the way, I've been there. For those that the listeners that haven't, right? You got a lot of testing stuff going on there. It's a big facility, and they have this room, right, where you test these loudspeakers for how long they can go before you blow out the cones or like whatever.
Power test room.
The power test room, right? Double constructed walls, and you walk in there. I remember it just sucked the oxygen right out of my. I mean, it was so loud in there. Double hearing protection, right?
Deafening. Yeah.
Talk to us about really about what that's like, because I think the listener, like, that's so unique. I mean, maybe not to the loudspeaker world, but to anybody that hasn't seen that or experienced it, it's kind of like being in front of a rocket engine. Not maybe it is extreme, but it's loud in there. Do you know how loud it is? And talk to us about that.
I'm not sure. I mean, that's that really. We would test these things in power tests, but the room you're talking about was the Pro.
Yeah,
and I never really worked in Pro. Pro is still located in the building, and certainly the facility has changed dramatically. There was a manufacturing line, and I used to be able to go out and see the Ultima stuff be made on the line.
That's awesome.
The wood shop was still there. All the Pro stuff was still made in Northridge at that time, and then some of it in Mexico. But you know, the times have changed, and in order to keep up with all the competition and the pricing, pretty much everything now is either made in Mexico or offshored.
Gotcha.
But all the engineering, or much of the engineering and the testing, is still done in Northridge, certainly for the Pro stuff. And in terms of one of those rooms, yeah, it gets really loud. I would hazard to guess that it could be like 140 dB in those rooms, you know, and it's kind of loud that, like, you don't just wear special headphones, you know, you also wear earplugs under your headphones so that you don't damage your hearing.
Yeah.
Double hearing protection.
Yeah.
So, yeah, you worked for Samsung. You worked for Samsung Research of America, right? Now you're back at Harman. I mean, as we're winding down here, the thing I want to know is, you've worked a lot in research and development and to expand these things and what they're capable of. Where do you see, you know, audio going? What's the next thing? What's the thing that's like everybody's focusing on right now? Because I'm sure you have to keep abreast of what's happening, right?
Yeah. Well, I mean, I really do think that you look at all the different really large manufacturers, or the big companies that are driving tech right now, which would be like Apple and Samsung and Google. And certainly you can see that there is an emphasis on spatial audio. I think that the idea is that now that Apple has their special chip inside their earbuds and their AirPods Max, the over-the-ear headphones, they're definitely pushing spatial audio, and you can see that they're pushing Dolby Atmos on you know, their Apple Music site. So it's coming. I think it's I've been talking with some of my friends, and I do believe that, like, it is true that it's a really tough sell. I think back to myself years and years ago when I was sitting in meetings at Harman, literally even in 2005, and we were talking about DNLA, the Digital Network Living Alliance. And the idea was, right, you know, going to take your music with you everywhere. And we were going to, at that time, we were trying to sell 7-channel systems, 7.1 systems. And I don't know about you guys, but most people that are my friends now still don't have a 7.1 system.
Nope.
And, you know, this is, you know, almost 20 years later. So my feeling is that the only way you're going to encourage customers to get to that point is to make it extremely inexpensive to have these systems. And right now you can't really do that because of the way that the technology is all set up. But as things change over the next 5 to 10 years, I could see that could happen, that the cost to make these systems could go down dramatically, and they would be very easy to produce, and you would just buy a full system in a box or whatnot that would deliver Atmos to you, kind of like the way you used to buy a Bose system, and it would come with all these microsats in a sub. I see that as being the future, and you just can't do it right now because of the way the patents and the technology are locked up. But I do think that that's the future as these large companies see it. Their goal is to sell more than one. So the idea is, like, how do I sell you a whole range of speakers, and how do I do that with the technology that I'm invested in inventing right now? which is, spatial, and the idea that they really want to get people into VR. And if you're going to have VR, you need all of the spatial cues. So not everyone wants to wear earphones, and that would be really cool to have a system. I think it does sell itself eventually, but it's just not there right now. The tech is not ready. It's still too expensive for the average person, and there's too much patenting out there or too many patents that prevent it from being ubiquitous.
You kind of mentioned earlier that engineering and audio engineering is somewhere where you kind of need to get somebody to lead you and guide you. I know it helped you tremendously. What is something that you want to say to people who might be looking into engineering, or they're like the college student who doesn't know what they're doing and they're trying to make that determination? Do they do like electrical engineering? Do they do mechanical engineering? They maybe love speakers and they are audiophiles. Like, what is it that you would say is most important and could relay over to them?
I think if you really have a passion for audio or acoustics, it is a very demanding and challenging field. There are not many schools in the U.S. or in the whole world that actually do audio engineering and teach audio engineering from the technical perspective, maybe from the music performance perspective, but not really from where you would make product. And so my recommendation is to don't be afraid to get out there, talk to people, find some really smart audio engineers to learn from, and learn everything you possibly can. And don't be afraid to fail. You will fail, and you're going to learn a lot, and you'll continue on down the path and just keep learning and keep teaching yourself. The audio industry is, I believe, a field of continuous improvement. It's constantly changing. It's at the forefront of technology. So you can't really be afraid to fail, because you're going to be constantly challenged all the time.
Thanks for coming on. Thanks for being understanding with the craziness that was for this podcast. I'm glad we were able to do it. I'm glad we were able to get back on. I think we had a wonderful conversation. Thanks.
Thank you, guys. Thank you so much. I really appreciate this opportunity.
Thank you.
Take care.